Hello and hi. In today's session, what we are going to learn is pupil reaction of different intensities of light. So we will just see what happens in bright light, what happens in dim light, how our eyes respond. So the first thing we have understood till now is the pupil size change when there is bright light or there is dim light. So pupil size generally change. That is one thing which we have understood. Pupil size always change depending on whether the light is bright or whether the light is dim. Now when the suppose light is very bright, when the light is very bright light, in such situations the size of the pupil is always a small. Basically what happens is, if this is your eye, this is your iris, the size of the pupil becomes very small. Why? Because not lot of light is required to get the information. To see an object, we just require little bit of light, correct? So if it is very bright, you don't require much of the light entering in your eye. All you require is little bit of light and you can see whatever is in front of you. So what happens is, to protect our eye and not to allow too much light to pass through our eyes, what our eyes does is, our pupil does is, the pupil size reduces. Basically it contracts. As you can see, the pupil size contracts. Pupil contracts. Why? So that eyes can be protected and we can still be able to see, let's say, the objects. So lesser light means, suppose let's say we can protect our eyes, because the light in this case is very bright. It's a very bright light, so hence we require little bit of light, so that for that particular purpose we require contraction of a pupil. But exactly opposite will happen if the light is very dim. If the light is very dim, what is going to happen? Our eyes we will not be able to see objects because it's very dark. So what our eye does is, our eye increases the size of pupil. The pupil size increases like this. See, it's very much big. Suppose let's say this is the initial pupil in bright light. In dark light, it becomes very, very large. Why? So that enough light can come into our eyes so that we can see the objects even in dark. So to see the objects in dark, we require a lot of light, let's say as incoming one in our eyes. So our pupil, what it does is, basically pupil expands. Pupil expands. Another word for it is called as dilation. So basically it dilates. So either you can say pupil expands or pupil dilates. So that is, let's say you need to remember the exam. In the exam, they will ask you what happens to our pupil in case of bright light. So in case of bright light, pupil contracts. And what about dim light? In case of dim light, it expands. Now let us go for second point. The second point is about persistence of vision. Now in persistence of vision, see, this is something, let's say a very simple point to understand. Persistence of vision. In computers or in laptops, you must have seen an option called as refresh, right? It can be used even in Google Chrome or let's say Edge, in whatever the internet browsers you are using. So technically refresh is a kind of, suppose let's say an option which you have seen frequently in case of computers. Now what happens is, when we see through our eyes, suppose we are seeing outside world, we saw suppose a dog or a cow. So its image is created in our brain. What happens is, through our eyes, we are creating images in our brain. We are creating images in our brain. Problem is that there is a certain period for which these images stay in your brain. So technically, there is one refreshment rate, you can say. So that means that image will remain there in your brain for certain time. And that certain time is how much? The impression of this image stays in the brain for about 1/16th of the second. 1/16th of the second. So this is called as persistence of vision. What is persistence of vision? That the image persists. Persist means what? Remains there. The image remains in our brain for how much time? 1/16th of a second. 1/16th of a second. See, 1 second is already small. 1/16th of it then means it is very extra small. So we can say persistence of vision is nothing but the amount of time, let's say, for which an image stays in our brain, and that is how much? 1/16th. So that is called as persistence of vision. Now what is the use of this? Suppose if let's say we move the images very fast, right? If we move the images very fast, then we can create some kind of motion, something like movies or something like cartoon. So the cartoons which were made previously, like in olden days, and suppose cartoons or animated movies, all those were based on simple principle of persistence of vision. Matlab, like you just move the images so fast that it will look like a movie. Something like your flip book. Let's say flip book also works on the same principle. Flip book, like that works on the same principle, that is persistence of vision. You move the images so fast that it looks like a movie is, let's say a movie is being played. So that is persistence of vision. Now let us go for defects of eyes. Now in defects of eyes, you have basically three defects. One is hypermetropia, one is myopia, and one is cataract. So first we will understand what is hypermetropia. Let us try to understand that. Hypermetropia. In case of hypermetropia, a person can see far objects. A person can see far objects. Can see far objects. Far objects means objects which are very far away. Can see far objects. Or you can say distant objects. Or you can say distant objects. You can also call this particular phenomenon is called as far-sightedness. Far-sightedness. Okay, so in hypermetropia, you can see far objects, but then what you cannot see? Nearby object. Can see far objects, but cannot see near objects. That means whatever is near you, near your eyes, that object you cannot see in case of hypermetropia. This is one kind of eye defect. Matlab, this is a problem in case of your eye, that let's say we cannot see the nearby object, but we can see far objects. Okay, question is how this problem arise, Okay, so that is one question, how exactly this problem arise. This problem arises due to one fact, that the image is created behind the eye, behind the retina. The image in this case is created where? Behind the retina. And why this happens? This happens due to shortening of the eyeball. This particular issue is created due to what? Shortening. That means your eye becomes short. Shortening of eyeball. Okay, let us see where the image is created. Fine. Okay, the image is created like this. Suppose this is your normal eye. This is your normal eye. The image is getting created where? At this particular position. This is your normal eye. Fine. The image is created at the retina. But there is a problem. Suppose in case of hypermetropia, the image is created like this. This becomes short. The eye becomes short. And the images, they are created where? At the back side. The images are created behind the retina. So that is called as hypermetropia eye, or hypermetropic eye. So technically this is what happens when your eye becomes short. So due to shortening, the images are created where? Behind the retina. And is there any solution for this? So yes, you can use convex lens to solve this problem. So whatever the spectacles you are using, so in case of spectacles, you have to use which lens? Convex lens. Use convex lens and this problem can be solved. Now there is another case, like just hypermetropia, there is opposite case, completely opposite to this, which is called as myopia. Okay. So in case of hypermetropia, we can see far objects. In case of myopia, we can see near objects. Can see near objects. It is also called as nearsightedness. It can also be called as nearsightedness or near sight. In this case, see, in hypermetropia, we cannot see near objects, right? In case of myopia, we cannot see far objects. Completely opposite. No, I told you hypermetropia and myopia are opposite. So in case of hypermetropia, we cannot see near objects. In case of myopia, we cannot see. In case of myopia, we cannot see distant objects. या फिर far objects you can say. Hypermetropia is created due to shortening of the eyeball. In this case, the defect arises due to let's say lengthening of the eyeball. This happens due to what? Lengthening. You can say the length increases of the eye, and because of that this problem arises, myopia. So this happens due to lengthening of eyeball. So where is the image created? Image is created in front of the retina. So suppose if this is your normal eye, the image is getting created here. Okay. Now after myopia, what is going to happen? The images are going to create, let's say, let me change that eyeball image so that you can understand it better. So the length is going to increase. Like the length is going to increase. Now the image will be created in front of the eye. That's the issue. This is where image is getting created. So this happened due to what? Lengthening of the eyeball. So your size increased. Correct? And in case of hypermetropia, you used convex lens. Correct? In case of myopia, we will use concave lens. So that is the difference. So they are completely opposite to each other. Hypermetropia, we can see far objects. Myopia, we can see near objects. Hypermetropia, we cannot see near objects. In case of myopia, we cannot see far objects. Hypermetropia occurs due to shortening of eyeball. Myopia occurs due to lengthening of eyeball. In case of hypermetropia, image is created behind the eyeball and behind the retina. And in myopia, image is created in front of the retina. The correction method, if you want to cure hypermetropia, you have to use convex lens in your spectacles. In case of myopia, you are supposed to use concave lens in your spectacles. That's it. Now, let us talk about cataract. There is one more last problem we have to deal of eye, and that is cataract. So let us see what this cataract means. See, what happens is that our eyes technically have muscles in them, and over the years in old age they become very weak. So technically in old age our eye becomes weak. Eyes and parts of it, eyes become weak. Okay, and many a times what happens is that let's say a cloud in your eye lens, a cloud is created. Cloud in the sense your eyes become cloudy. Your lens becomes cloudy. It becomes opaque. And as you know, it is the lens who is going to, let's say, help to create the image. So as the lens has become cloudy and it has become opaque, we cannot see anything in this particular case. So this, let's say when your lens gets cloudy or opaque, that condition is called as cataract. Happens generally in old age. So in old age, what is going to happen? Your eyes are going to become weak, and many a times your lenses, the lenses in your eyes basically will be cloudy and opaque. Now in such cases, what is going to happen? That condition is called as cataract. Question is, can we cure this? So yes, we can cure this. All you have to do is a little bit of surgery. And as which part is getting affected in cataract? In cataract, which part is getting affected? Eye lens, correct? So what we are going to do is, as it has become cloudy and opaque, it is of no use. So we are going to replace it with artificial lens. So all we have to do is, in case of cataract, do only one thing. All you have to do is have artificial lens, replace your lens with artificial lens through surgery, and your problem can be solved. Very simple. Okay, so we have discussed three things. We have discussed hypermetropia, myopia, and cataract. Now we will move on to visual challenges for some people. Person who cannot, suppose, let's say, see, let's say completely blind or partial blind, visual challenges related to them, we are going to study now. Visual challenges for some people. For some people means what visual challenges we are talking about? We are talking about people who are either completely blind or partial blind. So let us talk about let's say what kind of issues they have, or suppose let us say what are their supposed solutions for them. So the first problem is that if any part of your eye is not performing, it results into visual disability. Try to understand, if any part of your eye is not working properly, as we have seen all the components of the eye, ciliary muscles, lens, cornea, iris, pupil, retina, all those things, if any of them is not working, obviously your eyes cannot work. So technically it results into visual disability. Visual disability in the sense your eyes are not working because certain component or part of your eye is not working. So it results into disability of what? Visual disability. So it can either be due to two reasons. Visual disability comes due to two reasons. Either it can be a disease, either it can be a disease, either it can be a disease, or it can be from birth itself. Either it can be a disease or it can be from birth itself. Right? From birth you are having that issue, or it might be the result of some disease. Now you have to understand one thing. There are visual aids available. Visual aids. That means devices, we are having certain devices which can help people with visual disability. That means they are not able to, either they are completely blind or partial blind. So we can help them out. We have devices. So what are the names of these devices which we can use? So we have Braille typewriter. Okay, these are visual aids. Visual aids means basically devices which can be used by people with a disability, visual disability. So these people can use Braille typewriter. We have a typewriter which is of Braille, basically can help. Then talking calculator, as a person cannot see or cannot use a calculator with visual disability, for such people we have talking calculator, where you can, let's say, just name something, or let's say the calculator will just talk about it, even the calculation part. Then we have audio dictionaries as well these days. Audio dictionary. So these are certain devices which can help. So technically the Braille system has been used extensively for visual disabled people. So you have to understand two things here. In the exam, they will ask you what is visual disability, matlab like what it comes from. So visual disability is any kind of disability which results into let's say partial blindness or complete blindness. It occurs due to two reasons. First, it can be due to a disease, or it can be due to let's say it can be from birth. And there are devices available in the market which can help these people, and those are basically Braille typewriter, talking calculator, audio dictionary, and so on and so forth. So there are many devices in the market which can help visually disabled people. So that is all, suppose, let's say, from this topic. So thank you and bye bye.